Alright, so B would be equal to 14.7 inches, since they were using inches for their sides right here. Right here. Okay. So we have that angle C is equal to 27.6. Angle B is 108.9. And side B is 14.7 inches. Okay, now let's look at a triangle that's got an obtuse angle. So we've got 104. Okay, so if we go back here, for an obtuse angle, side 1 is always opposite the acute or given acute angle, so same setup here. And side 2 is always the other given angle. And then we're just going to compare side 1 to side 2. So let's go ahead and get the set up. Where there's my given obtuse angle. This is side number 1. This is side number 2. And we're going to compare those two to each other. So side number 1 to side number 2. So side number 1 is 26.8 and side 2 is 31.3. So side 2 is bigger than side 1. Okay. So if side 1 is smaller than or equal to side 2, yeah, because side 2 was bigger than side 1, we have no triangle. So there's only two cases with an obtuse angle. You either have no triangle or you have just one triangle. In this case, we have no triangle, and that is our final answer. Okay, now let's look to find the area of an oblique triangle. Remember, that's a triangle that doesn't have a right angle. So here's your formulas, but really what that says is if you've got a triangle and you've got this side and this side, well, you need the angle between those two sides in order for this formula to work. It says this is equivalent to 1/2 of the product of the two sides and the sine of their included angle, the angle between them. Okay, so for this one, they gave me the two sides and they gave me the angle between those two sides. So if I'm trying to find the area of this, all I have to do is 1/2 times both of those sides, and then times the sine of the angle that was included between them. So this would be around 584.9 feet. And since we're talking about area, all your units are going to be squared, so feet squared. And that's actually coming from right here. You had 34 feet and then 42 feet. So we had feet times feet, which would give us feet squared. So this would be your answer right here. Let's look at a word problem. Say we've got two radar stations, A and B, and they are 500 feet apart. And this is going to be A, this is going to be B, and this is going to be C, like you see right here. Okay, so the angle for A is 70, the angle for B is 60. We want to determine the distance of the boat from station A. Okay, so from the boat to station A, so from here to here, because that's station A. So really what we're trying to look for is this distance right here, which is the same thing as saying, okay, find side B. So that's what we're looking for. Okay, so what they gave us was an angle, a side, and an angle. So I have an angle, side, angle case, which means I'm going to use the law of sines. So they gave me A over sine of A, which is 70, is equal to B over sine of B, which is 60, and then C over sine of C, which we know what C is. That is 500. Okay, what I'm looking for is B. So in every expression, I have one unknown. So I need to get one more thing, which I can go ahead and get this angle right here. Because if I add all these up, so 70 plus 60 plus C, I know that equals 180. So that's going to give me 130 plus C is 180. So C would be 180 minus 130, which that would give me 50. Okay, so now I can replace this C right here with 50. Okay, now I can set these two expressions equal to each other. So we've got B over sine of 60 is equal to 500 over sine of 50. Cross multiply. So B times sine of 50 is equal to 500 times sine of 60. Divide both sides by sine of 50. So B is equal to 500 times sine of 60 divided by sine of 50, which when you plug this into your calculator, that will give you, and it says round to the nearest whole feet. So we will get 565 feet. So that's the distance from the boat to station A, is 565 feet. And that's it for this section.